Good morning children. We proceed on to exercise 8.2. Question number 7. Show that the vectors 2i minus j plus k, 3i minus 4j minus 4k, I minus 3j minus 5k form a right angle triangle. Call the three vectors as A vector, B vector and C vector. Now we need to check whether they represent the vertices of the triangle or the sides of the triangle. How are we to check it? If I add two sides, I must get the third side. Check it. I get A vector plus C vector is 2i minus j plus k plus what is C vector? I minus 3j minus 5k. As I simplify, it is 3i minus 4j minus 4k. So here we are learning how to add the two vectors. We add i's together, j's together, k's together. This is A vector plus C vector. And this answer is nothing but B vector. So whenever A plus C gives us B, it represents the sides of the triangle. So A, B, C form the sides of the triangle. Once I know the sides, let me find out the lengths of it. So what is modulus of A? It is squares to be added. 2 square minus 1 square plus 1 square. As I am simplifying, it is 4 plus 1 plus 1, that is 6. Square root, remember to write it. What is modulus of B? Again square root of 3 square minus 4 square minus 4 square. And my answer is 9 plus 16 plus 16, that is root of 41. Modulus of C vector. Root of the components no number tells us it is 1 plus minus 3 the whole square minus 5 the whole square. As I simplify, it is 1 plus 9 plus 25, that is square root of 35. Let me check Pythagoras theorem for the three sides, because my question is a right angle triangle. So modulus of A square plus modulus of C square is 6 plus 35. My answer is 41, which is nothing but modulus of B the whole square. So I am able to show sum of the squares of two sides equals to square of the third side. Therefore, the three vectors form a right angle triangle, and hence the problem. Question number 8. Find the value of lambda for which the vectors A and B are parallel. What do you mean by parallel vectors? One vector is a multiple of another. So let us consider A vector is t times B vector. What is A vector? It is 3i vector plus 2j vector plus 9k vector. That is t times B vector I plus lambda j plus 3k. As I compare 3 equals t into 1, I component. Now j component 2 equals t into lambda. K component 9 equals t into 3. From here we get t equals 3. Substituting 3 here, 2 equals 3 into lambda, or I get lambda equals 2 by 3. My question is to find the value of lambda, and lambda value is 2 by 3. We all should know to compare on both the sides I component. 3 here, t into 1. J component 2 here, t into lambda. And 9 in the LHS, t into 3. From this first equation, I arrive at t value. Putting t value here, we get what is lambda. Question number 11. If A vector, B vector, C vector are given, we need to find the magnitude and direction cosines of A vector plus B vector plus C vector. Let us write one below the other to ease our addition. So what is A vector? It is 2i plus 3j minus 4k. And what is B vector? It is 3i minus 4j minus 5k. What is C vector? As we read, it is minus 3i plus 2j plus 3k. We should know to add the three vectors. Addition tells us add the components together. 2i plus 3i minus 3i. Plus 3i minus 3i gets cancelled. We are left with 2i. 3j minus 4j minus j plus 2j. It is plus j, or else 3j plus 2j is 5j minus 4j is j. Minus 4k minus 5k is minus 9k. Plus 3k gives us minus 6k. As I know A plus B plus C, my question is to find the modulus. So what is the modulus formula? It is root of the squares to be added. 2 square, 1 square plus minus 6 square. So we get modulus of A plus B plus C vectors is root of 4 plus 1 plus 36, or I get root of 41. Now the question is to write the direction cosines also. So what are the direction cosines of A vector plus B vector plus C vector? Each component divide by the modulus. So I get 2 by root 41, 1 by root 41, minus 6 by root 41, and we have solved the problem. The second part of it, I need to find 3a vector minus 2b vector, 5c vector. As I see, it is 3 into, what is A vector? 2i plus 3j minus 4k. So we should know how to multiply by a scalar. 3 is a constant which I can write as a scalar. 3 into 2i, 6i. 3 into 3j, 9j. 3 into minus 4k, minus 12k. Remember to put the caps for the unit vectors. Minus 2b tells me minus 2 into b vector. 3i minus 4j minus 5k. As I multiply, minus 2 into 3, minus 2 into minus 4j, minus 2 into minus 5k. As we put the caps, we proceed to the third, that is 5c. 5 into, what is c vector? It is minus 3i plus 2j plus 3k. As we multiply each component by 5, 5 into minus 3, 5 into 2j, 5 into 3k. And now, my question is to add it all. 3a vector minus 2b vector plus 5c vector. As I add i's together, 6i minus 6i cancels. I get minus 15i. 9 plus 8, 17 plus 10, 27j. Minus 12 plus 10 plus 15. So 15 plus 10 is 25. 25 minus 12 is 13k. Now the question is to find the modulus. What do you mean by the modulus? Square root of squares to be added. Minus 15 square plus 27 square plus 13 square. As we simplify, we get 225 plus 729 plus 169. Square root of 1123 is the modulus of the required vector. Now I need to find out the direction cosines. each component divide by the modulus. Minus 15 by root of 1123, 27 by root of 1123, 13 by root of 1123, and these are the direction cosines of 3a vector minus 2b vector plus 5c vector, and hence the problem is done. Question number 12. The position vectors of the vertices of a triangle are given. We need to find the perimeter of the triangle. Suppose ABC is a triangle. What do you mean by the perimeter? The length AB, the length BC, the length CA. So to find out the lengths, I ought to know what are the vectors of the sides, that is AB, BC, CA. But in the question, they have mentioned position vectors of the vertices. That is A, B, C, the position vectors. So whenever I read the word position vector, I have to take the vectors as OA, OB, OC, where O is the origin of reference. So what is OA? As I read out from the problem, it is I plus 2j plus 3k. And what is OB vector? It is 3i minus 4j plus 5k. And what is OZ vector? It is minus 2i plus 3j minus 7k. To find the perimeter, we need the sides. So first side, let me calculate. It is AB vector. What is AB vector? We know the formula, second letter minus first. So OB minus OA. OB, as I read from here, 3i minus 4j plus 5k. I want to subtract OA. So change the symbol for OA and write it here. It is plus I will write minus I. Plus 2j, it is minus 2j. Plus 3k, it is minus 3k. For convenience, I am writing one below the other. You can also write near and do it if you are comfortable with that. 3i minus I is 2i, minus 4j minus 2j minus 6j, 5k minus 3k is 2k. So this is AB vector. I want the length of it, that is modulus, square root of. As we add the squares, it is 2 square minus 6 square and 2 square. As I simplify, it is modulus of AB vector 4 plus 36 plus 4. It is root of 44. The same pattern, we proceed on to the next side, that is BC. How to write BC? It is OC vector minus OB vector. What is OC from here? Minus 2i plus 3j minus 7k. Minus OB. So B vector, let us change the symbol. Minus 3i plus 4j minus 5k. Because I am subtracting, it means change the symbol and add. Now as I simplify this answer, BC vector is minus 5i vector plus 7j vector minus 12k vector. Once I know BC, what is modulus of BC? Root of squares. It is minus 5 square, 7 square plus minus 12 square, or BC modulus is 25 plus 49 plus 144. BC modulus, as I add it all, we get square root of 218. We proceed on to find the third side, that is CA vector. CA vector is OA minus OC. OA, as I read from here, it is I plus 2j plus 3k. Now I need minus OC. Let me change the symbol. Minus 2i becomes plus 2i minus 3j plus 7k. As we simplify, CA vector equals I plus 2i 3i, 2j minus 3j minus j, 3k plus 7k, 10k. And modulus, square root of squares, 3 square minus 1 square plus 10 square. As I simplify, it is 9 plus 1 plus 100, that is root of 110. Now the question is the perimeter of the triangle. So how to find the perimeter of triangle ABC? We need to add all the sides. Perimeter tells us to add all the sides, the lengths of each vector that we have found out. That is root of 44 plus root of 218 plus root of 110. As we cannot simplify it further, let us leave the answer like this. Question number 13. Find the unit vector parallel to 3a minus 2b plus 4c. Given a, b, c vectors. Let us find out 3a vector. 3 into, what is a vector? It is 3i minus j minus 4k. As we multiply by 3, it is 9i minus 3j minus 12k. Minus 2b vector, minus 2 into b vector we have written. As we multiply, it is 4i minus 8j plus 6k. Next we need 4c vector. 4 into c vector, I plus 2j minus k. 4 into I plus 8j minus 4k. Now we need to add it all. As I need 3a vector minus 2b vector plus 4c vector. 9 plus 4 plus 4, 17i minus 3j minus 8j plus 8j cancels. I am just left with minus 3j. Minus 12 plus 6 is minus 6, minus 4 is minus 10k. As we get this, we need to find out the unit vector. Unit vector equals a vector divided by modulus of a vector. So, unit vector we generally denote a cap. The formula is a vector by modulus of a vector. Here, I am given 3a minus 2b plus 4c. Let us try to find out the modulus of 3a minus 2b plus 4c. It is square root of 17 square plus minus 3 square plus minus 10 square. As we simplify, it is root of 289 plus 9 plus 100, which is root of 398. My question is to find the unit vector for 3a minus 2b plus 4c. For the entire vector, I want the unit vector. That is, each thing divided by root of 398. 17i minus 3j minus 10k. The whole thing divided by root of 398, and that is the answer. Question number 14. The position vectors A, B, C of 3 points satisfy some relation. What is the relation given? It is 2 into A vector minus 7 into B vector plus 5 into C vector equal to 0. Are these points collinear? We have a condition for collinearity. If A, B, C are the position vectors, we can say them to be collinear if and only if there exist non-zero real numbers, say x, y, z, such that the total x plus y plus z should be 0 and xa plus yb plus zc equal to 0. If I compare this condition here, xa plus yb plus zc equal to 0. As I compare, I get x is 2, y is minus 7 and z is 5. Let us check this condition. X plus y plus z is 2 minus 7 plus 5 and we arrive at 0. Therefore, we can conclude the given three vectors A, B and C are collinear. Question number 15. The position vectors of the points P, Q, R and S are given. We need to show that the lines PQ and RS are parallel. To show, we need to find out what is PQ and RS. Whenever I want to declare two vectors are parallel, one vector is a multiple of another vector. Let us find out PQ. What is given actually? Position vectors. The word position vectors tells us we need to write OP. So OP is I plus j plus k. OQ is 2i plus 5j. OR is 3i plus 2j minus 3k. And OS vector is I minus 6j minus k. To find out PQ, we know the formula second letter minus first. So it is OQ minus OP. As I copy OQ, K component is missing. So to ease our calculation, we shall write 0 into K component. OP, because I want minus OP, change the symbol. Minus I, minus j, minus k. As we simplify, 2i minus I is I vector. 5j minus j is 4j vector. 0k minus k is minus k vector. RS, we need to find RS. It is again OS minus OR. As we had written, OR, I want minus symbol, so change the symbols. Minus 3i, minus 2j plus 3k. As we simplify, I minus 3i is minus 2i. Minus 6j minus 2j minus 8j minus k plus 3k is plus 2k. In all the terms, let me take minus 2 as common. So I am left with I plus 4j minus k. And this is nothing but minus 2 into PQ vector. So as I have found out, RS vector is minus 2 times PQ vector. So this implies PQ and RS are parallel to each other. Question number 16. Find the value or values of M for which the given vector is a unit vector. Given M into I plus j plus k is an unit vector. Whenever I say unit vector, remember modulus of M into I plus j plus k is 1. Unit vector claims the modulus to be 1. Modulus of M is unaltered, right as it is. Root of the sum of the squares. 1 square plus 1 square plus 1 square, that is 1. So I get M into 1 plus 1 plus 1, that is root 3. That is equal to 1. Whenever I say modulus of M, we remember it should be plus or minus. So plus or minus M into root 3 is 1, or M equals plus or minus 1 by root 3. So we remember two things here. Number 1, it's a unit vector that claims the modulus to be 1. This is from vector concept. But when I am removing the modulus for a real number, for some scalar, removing the modulus claims us to put plus or minus. For the vector, we have put root of sum of the squares. So as we simplify, we arrive at M is equal to plus or minus 1 by root 3. Question number 17. Show that the points A, 1, 1, 1, B, 1, 2, 3 and C, 2, minus 1, 1 are vertices of an isosceles triangle. To show isosceles triangle, we need to show any two sides are equal. Sides Are they given in the question? No. They have given points. So whenever I read the word points or vertices, I treat them as position vector. So A is 1, 1, 1. How am I to write the position vector where O is the origin of reference? Each component, let us put I, J, K. So 1 into I plus 1 into J plus 1 into K. Similarly, what is B given? 1, 2, 3. So what will be OB vector? It is I plus 2J plus 3K. And C is 2 minus 1, 1. So what is OC vector? It is 2I minus J plus K. As I know the three position vectors, my question is to find out what is AB vector, because we need to find the sides of the triangle. So what is AB vector? It is OB vector minus OA vector. As we substitute OB and minus OA, change the symbol and write it. As I simplify, I minus I cancels. 2J minus J, J vector. 3K minus K is 2K vector. Find out modulus of AB vector. Root of 0 because I is missing. J component is 1 the whole square and K component is 2 the whole square. So AB the modulus is 4 plus 1 square root. So it is 5 root. Next we need to find out BC vector, that is OC minus OB. As we substitute OC and OB, we change the symbols. I keep adding 2I minus I minus J minus 2J, K minus 3K. And we get BC vector. Let us find out the modulus. Square root of squares, 1 square, minus 3 square, minus 2 square. As we simplify, modulus of BC vector is 1 plus 9 plus 4, or it is root of 14. Check whether modulus of AB and modulus of BC are equal. Are they equal? If they are equal, I need not proceed for the third side. But AB modulus and BC modulus are not equal. So let us proceed to find the next side, that is CA vector, which is OA minus OC. OA vector I plus J plus K minus OC vector. Change the symbol, minus 2I plus J minus K. As we simplify, we get CA vector is minus I plus 2J. K and minus K cancels. As I find out the modulus of CA vector, we get minus 1 square plus 2 square the whole square root, or modulus of CA is 4 plus 1, 5 the square root. Now we are able to show modulus of AB is equal to modulus of CA. That implies two sides of the triangle ABC are equal. Whenever I am able to show two sides are equal, I can declare triangle ABC is isosceles. So isosceles triangle tells us two sides are equal, and we have shown in the problem.